Hello everyone. Welcome to Academic Coordinates. This is an introductory video to geometric sequences for grade 12s. Alright, so geometric sequences, guys, differ greatly from arithmetic sequences, linear sequences, and quadratic sequences in that there is no common difference between its consecutive terms. But in geometric sequences, right? Geometric sequences, we have got a constant ratio. So we refer to this as R, right? As the terms continues, right? So in geometric sequences, to get the next term, right, we multiply the previous term by a constant value, right? So basically, in geometric sequences, there exists a common, ratio between consecutive terms. Like, for example, let's say we've got 5, 50, 500, 5,000, right? So let's say we've got this sequence right here, and then you are asked to determine whether this is a geometric sequence or not. To get the next value, we need to multiply the previous value by a constant value. So we are not gonna find the difference here, but now our R is gonna be the second term divided by the first term, right? That has to equals to the third term divided by the second term, right? Which must also equals to the fourth term divided by the third term. Do you guys get that? So this is the constant ratio that exists, right? Okay, let's check. 50 divided by 5, is that equals to 500 divided by 50? Is that also equals to 5,000 divided by 500, right? Okay, so 50 divided by 5, what is that? That is 10. 500 divided by 50, that is 10 also. 5,000 divided by 500, that is 10. So the common ratio or the constant ratio that exists in this sequence is 10, right? Okay, so this is a geometric sequence because there exists a common value that will multiply the previous term to get the next term, right? And also, guys, if maybe we had 5, 50, and then we had maybe a different value here that was not gonna be multiplied by the same value, right? As R is equals to 10, then that would not be a geometric sequence, right? Okay, let's check. Let's say we're given now fractions. 1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32, and so on and so forth. All right. So maybe we are asked to find here the common ratio, or rather to determine whether this is a geometric sequence or not. So we have to test for R. All right. T2 divided by T1. T2 is 1 over 4. 1 over 4 divided by 1 over 2. So let's just check here what this value will be. 1 over 4 multiplied by 2 divided by 1. This is 2 divided by 4. If you simplify it, it's going to be 1 over 2, right? So in order for this to be a geometric sequence, it means that we'll need to multiply every term by 1 over 2 to get the following term. So 1 over 2 multiplied by 1 over 2, that is 1 over 4. 1 over 4 multiplied by 1 over 2, that is 1 over 8. Like for example, okay, let's say we got, this is 1 over 2, right? So 1 over 4 multiplied by 1 over 2, this needs to give us this term. And in fact it does, because 1 times 1 is 1, 4 times 2 is 8, right? Then we continue. To get the next term, we multiply the previous term by the constant value times 1 over 2, right? This is 1 over 16, right? So this is this term. So to get the next term, we multiply 1 over 16, which is the previous term, by the constant value, right? The constant value is 1 over 2. That will be 1 over 32. So yes, this is a geometric sequence. Okay, so let's say now, instead of being given straight values, we are given, I don't know, numbers. No, not numbers. We are given, variables. Let's say we are given something like, I don't know, 3m squared, 9m cubed, right? For example. So let's say we are given something like this, and then to get this value, to get this term rather, we need to multiply the previous term by a constant value also to get this one, right? So r t2 divided by t1 is, t2 is 3m squared divided by m, right? So this is going to be 3 times 1, that's 3m squared divided by m, that's m, right? Okay, let's check. T3 divided by t2, that is 9m cubed divided by 3m squared. So 9 divided by 3, that is 3m cubed divided by m squared, that is m. Let me just put it here, guys. So it's m squared, right, divide by m. So this is going to be m to the 2 minus 1, then that is m to the 1. You can see that? So this one is going to be m cubed minus 2, right? On top there. So that's going to be 3m. Sorry, that's going to be m to the 1. You see? So I just wanted to remind you guys on how you do that. Okay, so basically there is the constant ratio. You know what I'm saying? So basically this also is a geometric sequence, right? All right, guys, on the next video, we're going to derive the nth term, Tn, the nth term of a geometric sequence. And this is a very important expression that is going to help us, to apply geometric sequences on a number of, occasions. All right, guys, do stay blessed and enjoy the rest of your day.